Welcome back to School of Civil Engineering. In this video, we're going to discuss about an important topic. What are the flexural stress? What are the flexural stress and what is its calculation equation? I will discuss about this video. And in our previous video, already I have discussed about many civil engineering basic topic, and also I have focused on civil engineering software tutorial. So you will find the tutorial required for a civil engineer in this channel, and also the basic point of civil engineering. So if you're new here, just press the subscribe button and let's start. So first of all, stress in beam. Now if we see that forces and couples acting on the beam cause bending. Okay, so and the shearing stress on any cross section of the beam, and deflection perpendicular to the longitudinal axis of the beam. When force and couple act on a beam, then it creates three things: bending, shear stress, bending or flexural stress, shear stress at any cross section of the beam, and deflection perpendicular to the longitudinal axis of the beam. So if column are applied to end of the beam and no force act on it, the bending moment is said to be pure bending. If there have no force on the beam, okay, but it will the force will act on beam, but no couples work on middle of the beam, it will work side of the beam, then this types of bending is known as pure bending. If force produce the bending is called ordinary bending. What is the ordinary bending? When force produce bending, suppose the force are working on any structure or suppose beam, so it will produce some bending, and this types of bending is known as ordinary bending. After that, flexural stress definition. So what is flexural stress definition? Stress caused by bending moment are known as flexural or bending stress. Clear? So the which types of stress created by bending moment, or which types of stress caused by bending moment, this is known as flexural or bending stress. Now if we try to see the formula, suppose this is a beam, cross section of beam, and its height is and b is the width, and suppose this is the neutral axis. After that, this is the top bar and this is the bottom axis, and this is the top axis, and middle is the neutral axis. So from a neutral axis to top will represent by C, and here if we draw the stress diagram, then we'll see that in top it will produce maximum stress, and at neutral axis it will produce the minimum the stress 0, and again bottom it will create from the neutral axis, when we will go in top it will increase the flexural stress, stress, and when we will go bottom it will also create flexural stress. So by using that equation we can find out our flexural stress, where m is the moment, maximum moment, c is the that fiber distance, and I is the moment of inertia. Here is the equation for finding I equal to b dot h to the power cube, and b dot h cube, b into h cube divided by 12. So you all know that about that equation as a civil engineer. Then c is the, here what is c is the value of half of height. Okay, so after that, section modulus. So from here we can also find out the section modulus. Here is equal to I by c. Section modulus is the ratio of moment of inertia and half of height. This is the section modulus, and so if we put the value of I and c here, this is the I and this is the c, then here is the equation of section modulus. And FB max, so if we use that FB max, if we modify that equation, so we can write that the equation m by s. So flexural stress is the ratio of moment of inertia and sorry moment, maximum moment, and section modulus, ratio of maximum moment to section modulus. This is the flexural stress, maximum flexural stress. And when you will do the math, you have to remember about that point. This is the equation that is very essential for find out the flexural stress in a beam. So thank you very much. Stay connected till next video. And if you think that that video is helpful for you, so don't forget to subscribe to our channel and like our video, share our video, and don't forget to leave a comment for your suggestion. So thank you very much. Stay connected till next video.